Welcome back to PA Academy. So we are still looking at nodal analysis, and this is example 5. So in this video, we are going to be solving this question. It says, using nodal analysis, find the current passing through the resistors in the circuit. So in this circuit we are having about 5 resistors, and we are asked to look for the current that is passing each of those resistors. And if you look at the questions closely, you see that it said what? Using nodal analysis. You can say using nodal analysis. So that's to say that there are actually other methods that you can use to actually get the current that is flowing through it, but the question wants you to use nodal analysis. So that's what we are going to be looking at in this video. So if you have been following so far since the beginning, if you have watched the last 4 examples, you can just pause this video and then use this one to test your knowledge on what you've learned so far in the course of this video under nodal analysis. So don't forget the step. Once you have a question, you try to identify how many the nodes that are there. You pick a reference node, you pick your current direction, and then you apply Kirchhoff current law. Alright, so just pause the video and attempt it, and then just use that to test your understanding. Alright, so let me solve it from your side. So what we are going to do now is to identify how many nodes we actually have in this particular circuit. So in doing that, so right there is a node, because this is a point of connection between 1, 2, and 3. So but I'm going to make it as our reference, which is a 0. This is also a node. Now where it can become very tricky is at this point. And if you look closely, this is the node, because there's nothing in between here and here. So this is a node, this is a node, and this same thing applies here. So at the end of the day, we are having a total of 4. This is now our reference. So we are going to be using just these 3. So let's call this VA, let's call this VB, and let's call this VC. So this is 1, 2, 3. So that's the only part I think that might want to look confusing at first sight, is the fact that you might be thinking that this is a node, this is a node, this is a node, this is a node. No, they are just 1, 2, 3, and then 4. So since we've been able to identify the node, we've picked our reference point. So now let's pick direction. Let's pick a direction for current. So for this particular side, I'll be picking this direction. It's just influenced by the fact that this current source is flowing through this direction. So I just want to maintain that direction. The same thing applies here. I'll just maintain that direction. So for every other one, you can just pick a random direction. So I can just pick something going downwards. There is no space. Okay, let me just indicate it down here. Downward for this part, and then so. And if you are watching this video, I want to encourage you to make sure you watch this particular example to the end, because at the point in this video, I'm going to be giving you a very, very important tip that will make your work very easier when you are dealing with nodal analysis, especially when you are having a circuit that is looking kind of like cumbersome like this, so that you don't do too much work. Alright, then for this, I'll just pick this direction. And don't forget the voltage source, the polarities. This is plus, this is minus, this is plus, this is minus. So now, I haven't done that. Now let's apply Kirchhoff current law to those 3 nodes, to this node, this, and this. So let's start with VA. So we're going to apply Kirchhoff current law to node VA. So in doing that, let's take a look at VA. So we have this is going into VA, this is going into VA. So this and this is one that is going out. So the one that is going into VA is this. So we already have the value of the current itself, 6. So we can just write it straight away. That will be 6, then plus. So that's sorted out for this. Then the next one that is going into it is from here to here. So it's coming from this node VC in this direction towards VA. So since it's coming from VC towards VA, we are going to be having VC minus VA divided by 5. Okay, I think those are the only 2. Then so that will be equals to, so let's look at the one that is going out of VA. The one out of VA we have from this node to this node, that will be VA minus VB divided by the resistance of the resistor divided by 2. Then on this side, it's going back to the ref, so that will be plus VA minus 0. That's from here like this to 0. Then we have a voltage source in between. So we have a voltage source of 5 volts, not 5 ohm. This is 5 volts, and it is going from positive to negative. So that will be minus 5 divided by the resistance of the resistor, which is 3. So now let's simplify this. So this is just, let's just put it as over 1. So just LCM. So this is 5. So this will be 30 plus VC minus VA equals to, so same thing we are going to do here. This is just LCM. 6 divided by 2, that's 3. 3 to multiply everything at the top. So we're having 3 VA minus 3 VB plus 2 VA. So this is 0. Then minus 10. Alright, so at this stage now, so let's cross multiply. So use 6 to multiply everything here, use 5 to multiply everything here. So we are going to be having 180 minus 6 VC minus 6 VA equals to 15 VA minus 15 VB plus 5 times 2, that will be 10 VA minus 50. Okay, so now let's just rearrange this thing to make sure it is properly arranged. So let me start with VA. Let me bring all the VA together. We have minus 6 VA. If this VA should come in, become minus 15. Okay, this is 15 and then 10, that's 25. So if you should come to this other side with this VA, that's 25 minus 25 and then minus 6, that becomes minus 31. Minus 31 VA. So let's see for VB, I'm having only one VB, which is minus VB. If you come to the other side of the equals to sign, it becomes plus 15 VB. Then there's a VC here, minus 6 VC. So this should be plus. This should be plus. So like I said, let's just be careful with the signs. This is 6 multiplied by VC, that will be plus. So this will be plus 6 VC equals to my then we have minus 50 here. If this 180 should come to the other side of the equals to sign, it becomes minus 180 minus 50, that's minus 230. And this is our equation 1. So when we apply KVL to node VA, we are arrived at this equation. We arrive at this equation. So now what we are going to do now is we are also going to apply KCL. Did I mention KVL earlier? KCL. So we are going to apply KCL to node VB. To node VB. Don't forget I said I'm going to be giving you one important tip as we continue in this example. Alright, so the same thing. Let's look at for this node VB, we have 2 incoming. Okay, no, everything are both are all incoming. So you can also have everything to be going towards one direction. So we have here is going into VB, this is going, and this is also going. So let's write an equation for it using KCL. So from VA into VB, so that will be VA minus VB divided by 2 plus VC, that's for this side, VC minus VB divided by 4, and then plus, now if you look at this side, you already have a current here, so that will just be plus 4, because we are already giving a value here for current, which is 4 amperes. So the current on this branch is 4, while that of this branch, current on this branch is what we are having here as VA over R. Alright, then equals to 0. So now let's simplify this. This is 4. So if you have to simplify this, so let's just have this as over 1 so that we can have everything to be over 4. So 4 divided by 2, that is 2. We use 2 to multiply everything here. So you're having 2 VA minus 2 VB. Then this 4 divided by 4, that's 1. Plus VC minus VB. 4 divided by 1, that's 4 times 4, that's 16. Plus 16 equals to, plus 16 then equals to 0. Alright, so are we good? So if you cross multiply, 4 multiplied by 0, that's still 0. So we are going to be having 2VA minus 2VB plus VC minus VB plus 16 equals to 0. Alright, so let's just rearrange this to make it look neat. So let's look at the VA. We only have one VA, which is 2 VA. We have in 2 VA. What about VB? We have minus 2 VB and minus VB. That's minus 3 VB. Minus 3 VB. What about VC? We are having only one VC here, which is plus VC. Then we are having 16. If this 16 should go to the other side of the equals to sign, it becomes equals to minus 16. And let's take this as our equation 2. I hope you are still following. If you are finding value, please give it a thumbs up. Alright, now the next thing you have to do is to apply KVL. I hope you can still see it. So let's apply KVL to node VC. Now, this is where I was talking about. I want to share something with you. Now, whenever you have a circuit like this, it's mostly common when you have a circuit with with a lot of meshes like 1, 2, 3, 4 and the likes, with different shapes. Now, if you look at this diagram closely, you notice that on this particular branch that leads to node VC, the only thing we are having here is a voltage source. Is a voltage source. Every other branches that we are having attached to this is having, like this is having a resistor, this is having a resistor, this is having a current source. So when you notice that a particular branch leading to a particular node is having only a voltage source, what you can do to make your work much more easier is just make sure that that branch itself, if that is the only branch that is having a voltage source leading to that particular node, if that's the only branch having a voltage source leading to a particular node, if there's no other branch itself having just a voltage source attached to the node, just make sure that is the only one leading to the to that node. I hope what I'm saying makes sense. Now this is what I'm saying. If you look at this close, like I said, this is a 2 volts leading to node VC. There is no other voltage source that is leading to VC. Now if you look at this voltage source here on this particular branch, there is a resistor attached to it. Exactly. So in this case, where we have just a voltage source, and that is the, if you notice the way I gave my direction, I just make sure that this particular branch is leading to VC. Every other thing is going out of VC. Why? Just to make the work much more easier. So that means the voltage at this point VC is this, because this is the only voltage that is going into VC. Every other thing is going out. So what that means is that, sorry, this should be KCL. Or let me just say, without even applying anything, let me just say at node VC, the voltage there VC is equals to what? 2 volts. You can see we don't need to do any calculation again. We don't need to start going through all these calculations. It saves our time and make our work much more easier. So when you have a branch and you have a voltage source, there's no other element attached to it apart from the voltage source. Just make sure that that's the only thing that is leading to it. Every other thing, you push them out. I think that's also another way to explain that. So just direct them to the other side. If you have a node, and maybe this one is having a resistor, this one is having a resistor, this one is having a resistor, and then you have one that is now having a voltage source. Exactly. So you can just make sure that that one that is having a voltage source is the one that is entering the node. Every other thing, you send them out. Let them be the outgoing. Let this one be the incoming. So that means whatever value you are having here, whatever voltage you are having here, maybe 5 volts, will be the volt at this node. So it's from that 5 that these 3 are what they are sharing. Maybe this one is 2, this one is 2, and this is 1. I hope that also makes sense. Alright, so with that, we've been able to pick 3 things from all these things we are having on the board. What are the things we want to pick? This is our equation 1, this is our equation 2, and this is our VC. These are the 3 things we want to pick. So because of space, I'll be cleaning these things on the board and then write out equation 1, equation 2, equation 3, so that we will continue with what we are asked to look for. Don't forget, we are asked to look for the current that is passing through each of these elements. We are almost through. Just remain one more line. So we are going to solve equation 1, equation 2, and equation 3 simultaneously. So let's quickly do that. Alright, so I've created more space, clean up those ones. So this is our equation 1, this is our equation 2. And remember we said that what our VC is what is 2. So to put it into this, we just have our 0, this is 0 VA plus 0 VB, then plus VC equals to what? Equals to 2. So once you solve this equation simultaneously, you can use your calculator like we've been doing before. So you just pick your calculator. I want to believe you should be good with this by now. So you press your mode button 3 times. 1, 2, 3. Equation, that's 1. Unknown, we have 3 unknowns. That is VA, VB, and VC. So that will be 3. And then it's asking for A1. So A1 is minus 31. You press your equals to button. Your B1, this is B1, that's 15. You type your 15, you press your equals to. To ask you for C1, which is 6. D1, which is minus 230. So minus 230. Once you put in, you press your equals to button. So you continue in that order. So A2, which is 2, the value here is 2. Then minus 16. So A3, you put in 0. For B3, which is 0. And then for C3, the value here is 1. That is like 1 VC. I hope you can see it. And then for D3, which is this, you put in 2. So when you do that, you are going to get your X to be, let me see, to be 15.809. So that X means our VA. So let me write it out. So that means our VA 15.809 volts, our VB 16.539 volts, and then our VC is equals to 2 volts. So now we'll be able to get VA, VB, and VC. But that's not what the question is asking us. The question is asking us to what? To find the current that is passing through the resistors in the circuit. So now let's start to look for that. So let's start with the 2 ohm resistor. This 2 ohm resistor, let's start to look for the current that is flowing through each of them. Now some question can just ask us to look for VA, VB, and VC. Assuming that's what the question asks us to look for, then we can just stop here because this is our answer. We've gotten the voltage at each of this node. But the question went further to ask us to look for the current that is passing through each of these resistors. So now let's start with the current flowing through the 2 ohm resistor. That is I with a subscript of 2. That means current flowing through the 2 ohm resistor. So if in doing that, you look at this particular branch where that 2 ohm resistor lies. So you write the equation there, the current equation. That is based on this direction. Now you can see the direction, the same direction we used to solve the question. Now we get VA, VB, and VC. So it is what? VA minus VB divided by 2. So that means our VA is what? 15.809, and our VB is 16.539. So that will be minus 16.539, then divided by 2. So let's see what that will give us. So that will give us minus 0.365. Then don't forget your units, amperes. Now we are having a negative value. So that means right there, the direction that we picked, we said is flowing in this direction based on the angle like this. That means it's flowing in this direction. I hope you can see that. That means this direction that we, remember we will pick a random direction because we are not sure, so we just assume. So the direction that we assume towards the right is not the actual direction that the current is flowing. That's why we are having a negative value. So that means the actual direction it is flowing is what is in opposite. That means to the left. That means it's actually flowing like this. So for us to indicate that in our answer, we'll have it as 0.365 amperes. So you can put it in brackets like this. So whenever you do this, it's just a way to show that yes, you really understand what you are doing. So that is it. This is the current that is flowing through the 2 ohm resistor. So then the next one that let's look at is Okay, we have a 3 ohm resistor somewhere here, so that will be I 3 ohms. So for the 3 ohm resistor, we are going to do the same thing. This is the direction that we picked, so that will be VA minus 0 to the reference point, and then there's a voltage here from plus to minus, that is 5 ohms, minus 5 divided by the 3 ohms resistor there. So that will be VA minus 0 minus 5. So our VA is what? 15.809. 15.809 minus 0 minus 5. So that's just like minus 5, then divided by 3. So what would that give us? Price that in your calculator. So that will give us 3.60 amperes. So this is giving us a positive value. So that means the direction that we assumed here of downward is actually what? The direction of the current. So that's why we're having a positive. So you can just indicate it there also. So that is it for the current flowing through the 3 ohm resistor, 3.60 amperes. Alright, so let's look at the next one for the 5 ohm. So the current flowing through the 5 ohm resistor. So for the 5, from VC going towards VA, that's the direction that we are having here. So that will be VC minus VA. There's no voltage source here, so that will be divided by 5. So what's our VC? Our VC is 2. That will be 2 minus VA, which is 15.809. 15.809 divided by 5. So that will give us minus 2.762. 2.762 amperes. So since it's a negative and now we want our answer to be in positive, so that means the current is not actually flowing in this direction that we picked or that we assumed. It's actually flowing to the right. So that will be 2.762 amperes and then to the right. Okay, so let's see which other one again. We've done 1, 2, this, so it remains that of the 4 ohm resistor. So the current flowing through the 4 ohm resistor. Please, if you are finding value in this video, please give it a thumbs up. I want to see that thumbs up on the video. Give it that thumbs up. Click on that like button. So the current flowing through the 4 ohm resistor, this is the direction, that is from VC to VB. So that will be VC minus VB divided by 4. So our VC is 2, that will be 2 minus 16.539 divided by 4. So that will give us minus 3.635. So since we are getting a negative answer, so for us to have a positive, that means the current is, we assume that the current is flowing in this direction, but from that we are getting a negative answer, so that means the current is actually flowing in this direction. So that will be 3.635 amperes, and let's indicate the direction. So with this now, we've been able to get the direction of all the currents in all of this of the elements in this, of the resistors rather, in this circuit. Now let me do something just for us to give us that to be sure that our answers are correct, So let me just, you might want to pause the video and write this down, because I want to create a space to explain 1 or 2 things for you before I round up. Alright, so if you look at this analysis I have on the board here, this represents this node VB, and this is the side with the 2 ohm resistor. So if you see the 2 ohm resistor here, we have it to be 0.365, and it's moving towards this direction like this. And while this 4 ohm resistor, we have it to be 3.635 amperes towards this direction, and then we also have a current of 4 ohm going upward. So if you are to analyze this particular VB, that means we have one incoming and one out, two outgoing. This is going in and these 2 are going out. If you look at this, 0.365 plus 3.635, it will give us 4. That means the total current going out is 1 coming in. If you also examine this, it's also the same thing. This is for VA. If you also analyze it the same way, you discover that the total current going in is also the one going out. So that's just what I want to explain. So this is the solution to this particular example on nodal analysis, you can see that using nodal analysis, you can also use it to calculate not only the voltage at some of the nodes, but also to calculate the current that is passing through some of the resistors in the circuit. So I hope you find value in this video under nodal analysis. So that is all I want to cover under nodal analysis. If you have any question or any comments, do leave them in the comment section. If you find value, please give it a thumbs up, please subscribe, make sure you share the video with your colleagues, and then with that, I'll see you all in another video. You can also check out our website, paacademy.co, paacademy.co. So thank you very much, guys. I'll see you all in another video.